Assalamualaikum warahmatullahi wabarakatuh. So, good morning, everyone. How are you today? I'm fine too, thank you. So, does anyone doesn't come to my class today? Not yet. Okay. So, before we start our learning, I want someone to lead the prayer, and maybe I will choose Fernanda. Can you lead the prayer, please? Okay, thank you so much, Fernanda, for the prayer. And before we start our learning, I want to ask you about something. Does anyone still remember about the material that I was giving you last week? Okay, Zainal? Great, thank you for Zainal. So we will learn about the Newton's laws last week, and I will review about the Newton's law, and I will give you three questions, and if you can answer, I will give you a reward for next class. So let's go. The first question is about how is the state of Newton's laws? Does anyone want to answer? Okay, Aisha, what is the answer? Okay, good. So the first law is talk about inertia, and then for the second law, we have to learn about acceleration, force, and mass, and then for the third law, we have to learn about action reaction. Okay, let's move to the next topic. To the next question. The second question is what is the mathematical equation of Newton's laws? Okay, Carlita, what is your answer? Okay, good. So for the first law, we have sigma f equals 0, and then for the second laws, we have sigma f equal mass times A, and then for the third law we have F action equal of F fraction. Okay, so for the last question it's about can you give me an example in your daily life about Newton's laws? Okay, Ravina. Okay, really good. Okay, for Ravena, Ferlita, and Aisha, please remember me to give you a reward for next week's. And then I think all of you is understand about Newton's law. So let's move to the next material. And today we will learn about the Kepler-Swan's law. And I think last week I was told you to learn first about Kepler-Swan's law. So I hope you have a general understanding about that. So let's go. Okay, so for the learning objective, there are 2 points. The first point is about understanding science. It is include describe statement Kepler-Swan's law, formulate equality mathematical Kepler-Swan's law, and analyze problems regarding Kepler-Swan's law. And for the second point is about process skills. It is included discussion for analyze result, observation, activity, discussion, problem about formulation equality mathematical Kepler-Swan's law and presenting result analyze about equality mathematicals Kepler-Swan's law. Okay, so before we start our learning, I want you to watch the video first about the phenomena of the Kepler-Swan's law, and I want some of you to ask me about some question in this video. So please watch and listen carefully. So let's enjoy the video. Okay, from the phenomena that I was give you, there is an equation about the video. Please raise your hand first. Okay, Septika, what is your question? Okay, so your question is about what is the difference between our pit planet 1 and the others, right? Okay, does anyone have any question about the video? Okay, Rosa, what is your question? Okay, so your question is about why do planets move regularly in their orbits, right? Okay, so thank you so much for the question. And before I answer about the question, first I will share to you about the worksheet Kepler's One's law, and I will divide you in a few group in three group. You can see there are group one, group two, and group three. And from the worksheet, you can have some understanding about Kepler's One's law. And after you're done about the worksheet, you must to present, and I will give you an explanation also about the Kepler's One's law. Okay, so this is the worksheet. You can read your theme and also remember in here, and then the title is Kepler-Swan's law. The goals is through the problem discussion method students can formulate the mathematical equation and Kepler-Swan's law. So this is the learning concept and also the discussion you can read by yourself. And then in this worksheet there are two problems. The first problem, you can analyze the equation from this picture, and then you can answer it. And then for the second problem is about eccentricity planet Mercury. And then after you have done with these two problems, you can have a conclusion. So you can read and also write down the state of Kepler-Swan's law and also what is the equation of Kepler-Swan's law. And after you have done with this with your worksheet, I will choose random theme to present, and I will give you maybe just 15 minutes to do your worksheet and maybe just 6 minutes to present it. So please have a good discussion with your team, and yeah, let's go to your team. Okay, thank you so much for group one for presentation about the worksheet. So I will give you an explanation about Kepler-Swan's law. So scientists initially thought the planetary trajectories were circular until finally Johannes Kepler concluded that circular trajectories were only in certain cases, while in general planetary trajectories were elliptical. Kepler-Swan's law is known as the law of elliptical path. Kepler's first law reads, all planets move in elliptical path around the Sun with the Sun at the focus of the ellipse. Okay, so this is the table that will answer the question from Septica. What is the different orbit between the planet one and the others? So you can see from this table there are many of planets, and you can see they are average distance from the sun, closest distance from the sun, farthest distance from the sun, and also eccentricity. I will give you an example about Mercury. The Mercury average distance from the sun is 0.39, and then from the closest distance we have 0.31, and for the farthest we have 0.47, and the eccentricity has 0.2056, and this value is different from the others. So this is the answer for me. Have you have any feedback, Septica, with the answer, with my answer? Not yet. So you have already understand about that? Okay. So let's go to the next matrix. Okay, so you can see from this picture, the first distance through the center of the ellipse and its two foci is called the major axis, namely along 2A with A called the semi-major axis. The shorter distance through the center of the ellipse is called the minor axis, namely along 2P with P called the semi-minor axis. If the local distance to the center of the ellipse is C, then the relationship between A, B, and C is written as the ellipse equation. So this equation, it seems like Pythagoras equation, right? So this is the equation about the ellipse equation. Okay, so in here we also have an equation. The first is A equal P times A times B, which is A is orbit area. A is distant from the center of the ellipse to the farthest orbit, and then B is distant from the center of the ellipse to the nearest orbit. And then for the second equation is R equal A times 1 minus E in brackets. R is distance between the planets and the sun at the point in orbit, and then A is half the long axis of the ellipse, namely the average distance of the planet to the sun, or kilometers. And then E is orbital eccentricity, namely the ratio of the farthest and closest distance of the planet to the sun to the average distance. The value A is always between 0 and 1, where a circular orbit has E is 0. Okay, so next, eccentricity of the ellipse. We have the equation is E equal C divided by A. For A circle, C is 0, and also value of E is equal 0 too. The range of E values for the ellipse is between 0 until 1. The value of the Earth trajectory is 0.017, and then the E value of the planet Mars as the largest, we have 0.21. Passage of Halley comet with E is equal to 0.97. Okay, so you can see from this picture, the sun is located at a focus of the ellipse. There is nothing physical located at the center as the black dot or the other focus as the blue dot. So you can see there are comet Halley in this orbit, and then this is the orbit of Mercury from the sun. Okay, so for the next, the distance between the sun and the farthest planet is A plus C. This point is called aphelion, or you can say aphelion. And then the planet's closest distance to the sun is A minus C. This point is called perihelion. Okay, for the last of our class today, I have some assignment for you. So there are four questions about the Kepler's one's law, and I want you to do this assignment, and you must to submit before class next week's. And have you guys any question about this class today? Not yet. Okay, so I think, oh yeah, I will share this assignment at WhatsApp group, and then you can submit in a classroom. So yeah, I think that's all for me. Thank you so much for your attention. Wassalamualaikum warahmatullahi wabarakatuh.